All right, Math 2 370 imaginary numbers review. In 3.7, we're going to use imaginary numbers, so we're just going over it so that we are all on the same page. Let's remember what the imaginary number is. I is the square root of -1. Or you could say that I squared equals -1. Both of those are true. We're going to more look at this guy here today, though. So, diving into number 1. The directions say to solve by taking square roots. So we're going to take square roots on both sides. So we'll take a root on both sides. Now, anytime we take a root in the middle of an equation, or if we put a root in, we need to put a plus or minus in. So we're going to have x equals plus or minus root -8. All right. Now, because there's a -8 underneath the root, we could rewrite this as x equals plus or minus root -1 times 8, which is the same thing as plus or minus root -1 times root 8, which is the same thing as I root 8. Okay? And now that I've shown us this, and now that we've gone over this, we can go straight from this step to this there. Okay? You don't have to do that work in the middle. Anytime there's a negative, you just need to pull that negative outside, and it turns into an I. So let me just rewrite this. We have x equals plus or minus I root 8. And now we need to see if we can rationalize, if we can simplify that root at all. So I'm going to take my 8 and I'm going to split it up into 4 and 2, and then again it splits up into 2 and 2. We're talking about a square root, so that means that we care about groups of 2. So I'm going to group these up into 2s. Here's a pair of 2s, and then we have a single. So this is going to be x equals plus or minus I root 2 times 2 times 2. You could do that step if you'd like to. These two 2's are going to come outside, and you have x equals plus or minus I, oops, let me rewrite that. Normally you write 2I root 2. Normally the I goes right next to the root there. And that's our answer. Okay, number 2. Now we have this -8 out front. To start off, I'm going to get rid of that 8. I'm going to divide both sides by -8. So we're going to have b squared equals, I don't know, what is that going to be? Is that going to be 3? Yeah, -3. We take our roots and we get b equals plus or minus root -3. There's a negative under our root, so I'm going to pull an I out. I have b equals plus or minus I root 3. Now, just like in number 1, we want to see if we can break that apart, see if we can make that root any simpler. 3, well, it doesn't split up at all. And because it doesn't split up, we know we're done. All right, that's number 2. Number 3. All right, again, we're going to have to get our x squared term all by itself, so I'm going to start off by subtracting 1 from both sides. So we're going to have 4x squared equals 396. I'm going to divide both sides by 4. And I've got x squared equals, I don't know what that's going to be. 396 divided by 4, that's 99. I want to take my roots. I'm going to have x squared, not x squared, I'm taking a root. X equals plus or minus root 99. Now, do I need to use an I in this problem? And the answer is no, because we do not have a negative underneath our root. You only use an I if there's a negative underneath your root. But we still need to simplify this out. So we've got 99, and we'll try to split that up. Well, we have 9 times 11 is 99. 9 can split up into 3 and 3. So we have a pair of 3's and a single 11. So we're going to say x equals plus or minus 3 root 11. Okay, that's number 3. On to number 4. First off, we'll subtract 1 out of both sides. So we get 6m squared equals negative 50. I'm going to divide both sides by 6. And I have m squared equals, well, that won't go into a single integer, but we can reduce it. Let's see what we get. If we reduce this, we have negative 50 divided by 6. That'll reduce to negative 25 over 3. Negative 25 over 3. We take a square root of both sides, and we get m, and I'll do this continue in blue. M equals plus or minus root negative 25 over 3. And I might have gone over this in a previous video, but whenever I have a negative with a fraction, I don't leave it hanging out front. I always put it with one of the numbers, and I normally go with the numerator. That's just what's easier for me. I found that if I leave the negative hanging out front of the fraction, I end up losing it while I'm doing the work. So I always put it with the numerator. Now let me rewrite this root. The root covers the whole thing. So if you have a root over a fraction, what's sometimes helpful to help reduce this, to help make this a little bit prettier, is to separate the root over the numerator and the denominator. Let me show you what I mean. So we got m equals plus or minus, and then we're going to have root negative 25 over root 3. Okay. We know what the square root of 25 is. Let me put an equal sign. We got plus or minus square root of 25 is 5, and then we have an I. And then we have root 3 on the bottom still. Now, we have to rationalize now. And what rationalizing means is we can't leave that root 3 in the denominator. We have to get rid of it. Now, the way to get rid of a root in the denominator is to multiply by that same root. So what I'm going to do here is I'm going to multiply by root 3 on the top and bottom. So really, like, I'm multiplying by a fraction that is equal to 1. So I'm multiplying by 1 in a fancy way. So what I've got here is m equals, I've got plus or minus 5i root 3 over, and then root 3 times root 3 is just going to be plain old 3. And there we are. That's the end. The reason for rationalizing, I used to think it was kind of silly. I believe that they started off doing that because calculators did not like to have roots in the denominator. And now our calculators will do it, but I know that college classes still require you to do it. That's what I had to do in college classes. And so I want to prepare you guys, if you do take math classes in college, that you're ready to be able to do that. So we will be rationalizing. Number 5. I'm going to start off by adding 4 to both sides. So we've got 3k squared equals 270. If you divide 270 divided by 3, you get 90. K squared is 90. Take our root, we get k equals plus or minus root 90. Now to split that 90 up, there we are. I'm going to take this 90 over here and split it up. This is 9 times 10. 9 can split up into 3 and 3. Well, we have a pair of 3's there. 10 splits up into 5 and 2. And neither of them have a pair, so they're just singles. So our next step is k equals plus or minus. Our 3's come out, and our 5 and our 2 stays inside. And we can multiply back together what's underneath our root. k equals plus or minus 3 root 10. Okay, this problem did not have an I. It did not have an I because this is positive. If what's underneath your root is positive, you do not have an I. Okay, number 6. I'm going to add 3 to both sides. So now I have 2p squared equals negative 20. I'll divide both sides by 2, and I get p squared equals negative 10. I'll take a root, and I get p equals plus or minus root negative 10. I've got a negative, so I'm going to need to use an I. So p equals plus or minus I root 10. I'm going to see if I can split 10 apart. It splits up into 5 and 2. There isn't a pair there. You can't pull anything outside from underneath the root, so we're done. There's our answer. Okay, number 7. I'm going to start off by subtracting 3 from both sides. So I have 2a squared equals negative 2. I'll turn this back into blue. I'll divide both sides by 2. So I get a squared is, well, that's going to just be negative 1. I take my roots, and I get a equals plus or minus root negative 1. Well, root negative 1, we talked about right at the beginning, is equal to I. So we have a equals plus or minus I. And the root went away completely because it was just a negative 1. If it was like a negative 5 or something, we'd still have to have a root with a 5. All right, that's number 7. On to number 8. We will start off by subtracting 5 from both sides. Minus 5, minus 5. We're going to have negative 8x squared equals negative 136. We'll divide both sides by negative 8, so we've got negative 136 divided by negative 8. Oops. And we get 17. So again, what I did there is I divided both sides by negative 8. So x squared equals 17. I take my root of both sides. X equals plus or minus root 17. And 17 is prime, and what that means is 17, if we try to split it up, we can't. You could only split it up by 1 and 17, and that's not useful. So that means that we're done.